next up, we are going to discuss filter mode. So first, I'm going to tell a little bit of what is being filtered, and then I'm going to like which data is being filtered, and then I'm going to discuss what is being filtered on, like which criteria is being used to filter. So there are many filters throughout the tutorials. Like this is, for example, filter, right? The date selection, the weekday selection, all filters. But in this case, filter mode is specific to the distance page, and it specifically targets this graph right here. That's also why we're going through it now. This graph right here and this data is the thing that's being filtered. Some small data being filtered here, but the most important part is that this data right here is being filtered, and as such also the data that this metric is being calculated on. So without paying any attention on what is happening on the background, if you put it to automatic, you can see the chart changes, the metric changes, everything changes. So if we then go to manual, I'm now gonna discuss exactly what is being filtered on. So we know what is being filtered, right? This right here. Now what are we filtering on? That's the next question. I want to show you by a little example. Say for example, right now we have P1 at hour 2 and P2 at hour 6, and the distance is negative 3.2%. So we can put that in. We're on manual input mode for the sake of argument. We can see only 15.3% of the days have a P1 that is further away from the daily open than we currently have. AKA there's a very low probability of that P1, P2 flip, because it doesn't happen often that price moves this far from the daily open and then goes back up. So, for that, you have to watch the previous video if you haven't already, where we discuss the P1, P2 flip. But the important thing to understand now is that, we have this distance from daily open to P2, and we can see that 15.3% of days move this far. Have a P1 this far from daily open, negative 3.21% or further, right? So again, low probability of a P1, P2 flip. But here's the ticker. We know some more information. We know that P2 is at hour 6, right? We know P2 is at hour 6. What we could ask ourselves is, well, is there any difference between, any difference for how far a P1 is from daily open if it gets put in around hour 6, so to say, So say for example, does it matter when the pivot is being put in? I'm just going to show you by an example to make it clear. So right now, we're just looking at all the days we have selected here, all the days. But we know P2 is at hour 6 in our example. I'm doing manual, I'm at look back mode. So if you're confused why this is hour 10, we're looking back in the past. So this is hour 6, right? And what we could say is, well, what would the percentage be if we would filter only on the days that have a P1 around that hour? So let's say hours 3, just the morning hours, let's say 5, 6, 7, and I'm going to explain why I'm selecting these more often. So we had 15.3%, remember that, and now suddenly it's 30%. 30%. So we can see that that's a big difference, right? When we were looking at all data, only 15% of days had a P1 further away, so it was very low probability. When we look at only the days that have a P1 around between hours 3 and 12, let's even remove 12, between 3 and 11, it's 28, let's keep 12 for a second. It's 30%. So that's double, right? So suddenly we have we can be a lot less confident in saying that P1 will hold. We can still be, it's still an edge in this case, but it's not the same as 15%. Now, why is this such a difference? Well, the reason why there's such a difference is because the time in which the P1 is put in matters for how much distance it is. How much distance there usually is. Let's revisit something when we say price is energy. When the price opens, it needs time to move, right? And the more time it has, the more time has passed, the more time it has to go further away from daily open. So the logical conclusion is, the closer you are to daily open, the less time price has had to move away from daily open, and thus the closer it will generally be to daily open. So the closer you are to daily open in terms of time, right? So the closer you are in terms of time, that also means that the P1 will be closer in terms of distance. So let's dive into that a little bit more by looking at this graph right here. So this graph is important. We're going to take this graph with it. With this graph, you see the average distance between daily open and P1 by P1 hours. So that means which hour of the day puts in a P1. We can see here, for example, that the average distance of the daily open to P1 when P1 is put in during hour 0 is 0.7%. We can see that at hour 1, this is already 1.4%. And then you go on and you see, for example, here at hour 12, it's already 3%. The orange line is a regression line, which basically shows the relationship between these two axes. So the distance of daily open to, so this on the y-axis is the average distance of P1 to the daily open, and this is the hour. And what it basically shows, the orange line, you can see slightly going up, is what we just discussed. It means that the later the hour P1 gets put in, the further away from the daily open that usually is on average. And this is why it's important. So the main takeaway I want you to take off from now is that it matters when the P1 is put in. If it's later in the day, that is generally later on, that is generally with a bigger distance than it is when it's earlier in the day. And that's the reason why you see such a big difference here, because we know, like, if we just look at hour 0, you can see how close that usually is to daily open. So if we just look at hour 0, we can see only 2.1% of days move this far from the daily open. And that is because it just lies closer, it's just way closer to the daily open. The price has less time to move. So we want to filter that out because we know at this point P2 is at hour 6. So we don't need to look at the distance between daily open and P1 when P2 is at, or when P1 is being put in at hour 0. We already know that if the P1 P2 flip were to happen in this case, if this were to happen, we know that that would mean that P2 would be put in at hour 6, right? Because we'd have the P1 P2 flip. So we have already seen that taking hour 0 in there heavily biases the metric here, because this is going to give you too conservative of an estimate, because we know P1, if the P1 P2 flip would occur, then again we're trying to estimate the likelihood of a P1 P2 flip as per discussed in the last video. But we know there's we're looking for that P1 P2 flip, and we know that if that P1 P2 flip were to happen, it would not be during hour 0, right? It would be in hour 6. We also know that hour 0 generally puts in a P1 closer to the daily open. But since we know that's not relevant right now, we can say, well, you can say I'm not interested in data days where they were put in a P1 at hour 0. So you can already see if you delete hour 0 that this will probably already change quite a bit. So you can see it already goes to 21%. That's because hour 0 by itself is the most different from all the others. Like these right here, I know they're high up, but you have to understand that P1 hour 16 doesn't happen a lot, right? So this probably happened like a couple of times, and all those couple of times they were far away. So you have to understand that the further you go, probably the less, or well, that's not entirely true, but these don't have much data, right? So I would pay less attention to these, especially to this one. Like this probably happened once or twice. But anyway, we know that, hour 0 generally is closer to the daily open. We know that it won't be the P1 anyway. So we want to filter that out to get a more accurate description of where, of the likelihood of P1 holding. So basically, to round that up, what you're asking here, if we're filtering and we're removing hour 6, so let's go, removing some other hours. So let's just take this selection here. What we're now looking at is what are the odds of a P1 P2 flip happening when P1 is at around this hour, right? Around here. when P1 is put in around here. So we are basically taking this range right here and saying, well, if P1 is put in this range, how far is that usually? And we can see, well, that happens 27.6% of the time. So that's why filtering is important on this data, because you can see that 27.6%, while still an edge, it does make a big difference, right? And if you would include all the hours, including hour 0, then you would just get a much very biased view of how things of the actual statistics, right? Because again, in this case, hour 0 is included, but we know that P1 is not going. If we have the P1 P2 flip, it's not going to be hour 0, and we know that it's generally closer to the daily open, so we don't want to include that in our data when we're analyzing this. So that's why we use this kind of filtering. So that's manual filtering. And one more thing I want to make is that I would not recommend filtering on just 1 hour. So if you do, for example, hour 6, just hour 6, because you could say, well, the current P2 is hour 6, let's check that. But you can see there's only 29 days that had a P1 at hour 6. So you're diluting the data too much, right? You cannot really draw any conclusions from this. That's why I was selecting multiple ones. And that brings me to the next one, which is automated filtering. Now, first of all, what I want to say is if you want to use automated filtering, is that you always have to have input mode on P1 automatic or P2 automatic. Otherwise, it won't work. We'll get to that. But what automated filtering does is it chooses automatically. It basically does what we just did manually. So what we just did is that we picked a couple of hours. And the reason I picked those hours is because if you look here, you can see that hours 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see all of them here kind of have the same average distance from daily open to P1. So this means that if P1 is put in during hours 3 to 11, so to say, they are more or less at the same distance from the daily open from each other, you know, whereas hour 0, for example, is usually a lot closer to the daily open. So what we can therefore do is, well, all these hours usually put it in around the same distance. That means we can cluster them together because we know they have similar data points, they have similar distances, so we can use them together and derive data from that. So that's why I said, all right, let's take hour 3, 4, 5, 6, and you know, and so on, and then you get those. And because we know these data points are more or less equal distance usually, they have a similar behavior, and you also get more days now to work with, right? In this case, we have now 218 days, so it is already a lot more feasible to actually draw some conclusions of this. Now, what automated filtering does is that because you can see this is kind of a tedious task, but what automated filtering does is that it does this for you. So if we now, for example, go to real time, which is a little bit further, we now have P2 at hour 10, so we did hold that P1, right? We did see it was more likely, it was a 28% chance or something. But what we can do now, so again, you need always automated. Let's stick with P2 automated. If you want to use filter mode automatic, use input mode automatic. Either one, P1 automatic or P2 automatic. What automated filter mode does is that it looks, so right now I have P2 automatic selected. It looks at, okay, when is the current P2 hour put in, which is in this case hour 10, and then it will automatically select the hours that are the similar distance, right? Have the similar average distance between daily open and P1. So if I put filter mode to automatic, what you see here is whatever remains blue is the hours you are filtering on, and whatever is gray is not being considered. So we can see that hours 0, 1, and 2 are not being considered, and also the afternoon hours are not being considered. And you can see that here, because now at the selection, we only have hours 3 to 11 available to us. So basically the whole process we just did with manually selecting a cluster of hours. So that's what it does. It selects a cluster, right? We're selecting a cluster of hours that have more or less the same behavior in terms of distance. So the hours in which P1 gets put in at more or less the same distance. So you can see this group right here is more or less the same distance, but these ones are usually further and these ones are a little bit closer to daily open, especially hour zero, right? Hour zero makes the most significant impact. So it's always important to fill that one out. So what we're doing now effectively is saying, instead of, so the difference is if I've this selected, so manual filter mode, now we're looking at, okay, what is more or less the probability of a P1, P2 flip happening based on all days, right, on any hour. And what we do now, what is the probability of a P1, P2 flip happening when P1 is put in around between hours 3 and hours 11 UTC, right? That is the difference. So you're more specific and therefore you get more accurate data to make decisions on. So this filter mode, it's pretty important whether you do it manually or automatically. If I use P1 automatic, right, which takes the current P1, then you can see this will change. And now it has picked hours 2 and 3 together because P1 is at the current hour 2. Now, obviously, this is a different use case. Again, I've discussed it in a previous video, but P1, this is not going to change anymore, right? P1 is P1, and it will either get taken out or it will just stay P1. So I don't want to get into like how to apply this because, like I said in the last video, I personally don't use it like that. Maybe you do, but for now, it's just important to understand that because current P1 hour is hour 2, it will select these 2 hours. So we're looking only at those hours, which you can see is different if we would look at all the data. In this case, it's not that different even. It doesn't always make a difference, but usually it does. This is actually quite rare. Either way, now you understand how this works. There is one more thing I want to make you aware of. And it is very important to understand, so please pay attention, that say you have a situation, and this can happen on any time frame, where P1 and P2, let me draw it out, where both P1 and P2 are put in at hour 0. So when it happens like this, and then you go like this. So say this happened. Let's say this happened, right? P1 hour 0 and P2 hour 0. P2 hour 0. All right, well, and if P2 is hour 0, then naturally P1 has to be hour 0. The thing to keep in mind is that if you have automated filtering selection in a situation like this, so let's say, for example, the distance of daily open to P2 is 2%, or let's say 1%. Let's say 1%. And you have automated filtering selected. In this case, I cannot do it because I want to emulate this situation. So what I'm just going to do, what will happen with automated filtering is that you have only hour 0 selected. Now, I just said don't select single hours because it doesn't have enough data. The only exception is hour 0. And it's the same for every time frame. Like the first time block just puts in the most P1s, and therefore you usually have enough data by just going on hour 0. Plus, it behaves so differently from the rest that you kind of want to have it separated. From what I've seen, obviously you could choose to do differently, but that would be my recommendation. But so what basically what we would be looking at now is that we see like, hey, this hypothetical scenario, but this can happen. What we see is that there is only in 19% of days would we take out that P1. So we can say, well, that's safe, right? And it's a valid conclusion, but the mistake people make in this kind of filtering is that they say, well, then I'm going to long and I'm going to keep it long for the rest of the day because it will hold for the rest of the day. But you have to understand that because of automated filtering, right now we're only looking at days where P1 was during hour 0. And this can change. This can change if we take out P2 during a different hour. So what we basically have to understand is that this probability is for these 2 pivots. So it's not saying like, okay, what is the chance that it will hold for the rest of the day? It is saying what we can derive is what is the chance that either of these will hold. And we can see that, well, this one, either of these will hold for now, right? So we can see that this one's likely to hold and this one's unlikely to hold. But watch what happens. If we were to do, let's say here in the afternoon, if we were to do this, right, just slightly take out P2, slightly take out P2, what would happen? What would happen is that we now have an afternoon pivot. So what is going to happen with automated filtering is that now it's going to look, okay, what are the chances of putting in P1 this far from daily open during the afternoon hours? So then we select the afternoon hours and look at that. Look at that, right? So I mean, it would be a little bit less because obviously, you know, maybe let's just do that for, let's say it just swept it with a couple percent, a couple decimal points, so 1.2%, but still, there you go, right? So suddenly, price went from a 19% probability of P1 well, you know what I mean, a 19% occurrence of P1 being taken out, more or less historically, to 72%. So at this point in time, it was indeed a very low probability to take this out because it just doesn't often happen that hour 0 puts in a P1 this far away. But now that we took it out in the afternoon, we put in a P2 during the afternoon, so say hour 16 or something. Suddenly it changed, because suddenly now we have to look at data of like, okay, what are the probabilities of putting in a P1 this far away from daily open during the afternoon hours? And we already know that, you know, we've talked about this, the further away from daily open we get in terms of time, the more time price has to put in some distance, right? So therefore, this is exactly what is happening right here, where you see this difference. It's simply showing that, you know, we are later in the day now, and therefore we've had more time, and it happens more often that price puts in P1 at this distance during this hour, right? So during this hour, it was not likely to put in a P1, but during this hour, it is in a high probability area. So the implication of automated filtering is that you have to understand that if P1 and P2 are at hour 0, a situation like this might occur where you go from a low probability of taking out P1 to a high probability of taking out P1. And it's just something important to understand. The most extreme examples of this, like this is obviously very extreme, 19% to 72.8%. But the most extreme examples happen when P1 and P2 are at hour 0. This is obviously always a thing to keep in mind. So for example, if we have P1 and P2 at hour 4, both of them, the same could happen. But the thing is that the distance between hour 0 and all the other hours is bigger than the difference between any of the other hours. So what I'm trying to say is that here, this difference between hour 0 and hour 1 is bigger than the difference between hour 1 and hour 3, 4, and this is just filtering out hour 0 makes the biggest difference. So what I'm trying to say is that if you have a P1 and a P2 at hour 4, for example, then the same theory of this applies, but the difference in percentages will not be as drastic. But it's important to understand that this can happen, right? Especially when you have P1 and P2 at hour 0, then you want to be aware that this can happen, right? So if you see P1 and P2 at hour 0, then what you're looking at is the probability of each of these pivots happening, a holding, or the P1 holding for this time, right? But if you take it out, the probabilities might change. So you wanna be aware of that. What you could also do, for example, is just select the hours that are further away. And I'm gonna make different filter modes where, for example, you could say, no, I wanna see what the probabilities are for this holding for the rest of the day as well. So for example, what you could do now at hour 10 is that you would remove all the hours that came before, or all earlier hours. And if you would have it like this, then you would have more or less a good probability of, you know, how likely is, let me just put it like this, how likely is this current pivot to be taken out for the rest of the day? Because now you're including all the hours that come later as well, right? All the days that have a P1 that was put in later than what we currently have. But for now, it is just important to understand that this can happen. And once again, I like to emphasize, this is especially the case when P1 and P2 are at hour 0. The other cases are not this extreme, and the differences are less when you do take it out. So a very special note, once again, that you want to pay attention to this when P1 and P2 are at hour 0. Please be aware of this. Again, I will probably make another filter mode that you can choose how you want to see it, but I'll make an update video by the time that comes. So that's all I have to say for this video. I hope it makes sense. I know it's a little bit more confusing. There are written tutorials as well. You can view those in the Discord, and in the written tutorials you can always see what the clusters are. So we know that it's selecting clusters when we do automated filtering, and in the written tutorials you will see what the clusters are. I'm just not showing it here because there's probably a chance that they will change, and therefore it doesn't make sense to put them in this video because you might just get confused. But if you want to see them, check out the tutorials in the Discord, and it will definitely be mentioned there. So this is automated filtering, a little bit more complicated one, but I promise you this was all the most complicated stuff we've had to do. For the distance-based statistics, from here on it's going to get easier. So I will see you in the next video.